So welcome. Geometry, we're going to cover 4.08 and 4.09 today. And don't worry about those documents that it's asking you to save. That was for an earlier class, so just X that little box out. Sorry about that. But welcome back from spring break. We were talking about all the adventures that we had, so I forgot to hit record. Anyway, what I was saying on this slide is this formula should already be on the formula sheet that I shared with you guys in a Class Connect, but if you didn't get that, it's under course materials. Should be there. Let me know if you don't see it, but it, like if you scroll all the way to the bottom, it should be there. So what this formula is showing is if you have a tangent line to a circle and the angle between the tangent line and a chord, so this is just, it's not the diameter necessarily, it's just any chord. If you take the measure of the arc and you take half of it, that would be the measure of this angle here. Okay, so that's something that we'll talk about in 4.08. All right, so this one I think you'll get a chance to give it a try. Let me change your polling tools to A through D. So if you finish this before I do, enter in A through D up there. Okay, so it says, what is the measure of angle ABD? So here it's really important to notice the notation. So this is wanting an angle measure between two lines, angle ABD, if the measure of arc BD is 130. Okay, so hopefully, yeah, after seeing that last formula, hopefully this will be easy. But arc BD is actually the distance on the edge of the circle, this arc here. And it's wanting to know, it's telling you that that is 130. And it's wanting to know what this angle right here is. So if we go back to this screen, that's what this is demonstrating. It's saying, okay, if you have a tangent line, what is a tangent line? Can you guys remind me about that since we had a week off? Got to refresh our memory. What's a tangent line? Good. It intersects the circle at exactly one point. So it's just right there. It's where it touches the circle. Even though it kind of looks like it's crossing here, and it might actually cross in that picture, but it's, theoretically, it only touches in exactly one point. Yep. So if you have the angle between the tangent line and a chord, if that's what you're looking for, you're going to take half of the arc. So notice that the arc, it's important too on this formula to notice which way that is going. It's going where that angle is being formed. It's going in that direction and going around to the other side of the chord. Okay? So in other words, it's on the same side of the circle where the angle is at. And the reason I bring that up is sometimes they'll give you, so for example, maybe they gave you this arc down here, and you're like, okay, I just need to take half of that, and that would be the angle I'm looking for. Well, that would actually be this angle right here, but if you were looking for this angle, you would not quite have the right answer. So what you would want to do is subtract 360 from this arc so that you could get the correct side of the circle. So just pay attention to what side of the circle it's on, okay? But yes, in this, you can see here that the angle that we're looking for and the arc are on the same side of the circle. Does that make sense what I'm saying there? Do you see what I mean by like on the same side of the circle or on this side of the line? They're both on that side of the line. Okay, so yeah, and I saw Atira had it correct up above. He just took 130 and took half of it, which looks like what most of you did. You guys were super quick, which is awesome. So yep, D is the correct answer there. Oh man, sorry I turned off my mic there. I had a big sneeze. I don't know if I have a cold or allergies, but one of the two. Thank you. Thank you. Yes. Oh, it's just the cutest thing. My youngest daughter, she's 20 months, so she's just, the little baby talk stage, but she can say, bless you now. So when we sneeze, that's what she says. It's just super cute. Oh, I hope not a Tiro. That would be really bad if I was allergic to that. Oh, oh, good question, Devin. Let's see. Um, that is a good point. Let's see. What would be the? I think it would be that was. They are 90 degrees to like the diameter of the radius of the circle. So that's the extra clarification in there. So here it's just a chord, like any old chord. Good point. Yes, I'm glad you thought of that because that could be confusing. But if it was like from B to F, then it would be 90 degrees, which does make sense, right? Like if you think about that, if we had drawn the very funny, Atira, very funny. If I had drawn the radius from B to F, or let's say we do the diameter, since that's a chord, let's say, okay, well, let's figure out this angle right here, and we know the measure of this arc, if it's a semicircle, is 180. If you take half of that, that's 90, which would make sense, right? Gotcha. Yeah, and, you know, Devin, sometimes, if you find that, maybe let me know, because sometimes, you know, they might, since we hadn't really talked about chords and tangents at that point, they might not have put that in there. But that is definitely something important to note. So the tangent is always going to be 90 degrees to the radius or the diameter. But if it's another chord, then you would use the formula a couple screens back. Good clarification, though. That's great. Okay, so here, let's see what we have. We have arc BD, which is 110 degrees. So it's the same as the last one. Oh, see, I warned you guys about this. In this problem, we want the measure of angle CBD, which would be this angle right here. So what are you going to have to do? Anybody want to try this one on the whiteboard? All right. Oh, you guys are both quick, but Nate was a little quicker. So there you go, Nate. You have whiteboard privilege. Show us how to do this one. Oh, okay. Do you know, Devin, what was that from 4.08? Do you remember what quiz that was off of? Oh, no, Amelia. That's awesome. I love it when you guys get on the mic. Well, darn it. You're going to have to be faster next time. How about the next one? If you want to do it, I will let you have first choice. Good. So you can see that Nate is subtracting from 360 first, because what we really need, because like I was pointing out earlier, the angle that we're looking for is on the other side of the chord than the 110 degree measure of the arc. So we actually need to find out this arc measure first. Or like Atira, I don't know if you guys saw what he did up above. You might scroll up. He started out by finding an angle and then subtracted from 180 to get the angle that he wanted to, which would work. Because if you notice, angle ABD that we found out in the last problem and angle CBD that we're looking for in this problem are supplementary because they form this line. Okay, so that's what you find. Like the farther we get into semester 2, the more you'll see. That's what I say. This unit really, especially unit 4, it's like a big puzzle because you can start to use all sorts of things that you've been learning all year. So that's what makes it really fun and also challenging at the same time. But yes, excellent. So over here, this arc would be 250, and then if you take half of it, that will give you the angle. Very good. I saw a lot of you guys typing in A, and that is correct. Are there any questions on what Nate did there on the board, or any questions about how to get the right answer here? Okay, good. Yeah, Devin, let me know if you find that quiz question, because I'll have to. Oh, 4.03 you said. Okay. Okay, let me look. I'll take a look at that, and then we can come back and touch on that if we need to, if there's some sort of a mistake on that, because there definitely could be. It does happen. Oh. Now, what does it say? It claims that it has to be perpendicular to be tangent. Oh, okay. And they don't add anything in there about radius or diameter, huh? Oh dear. Okay, well, yeah, I'll grab that, and that would actually be a good thing to point out. Yep, I am glad that you mentioned that, Devin, because that is a very good point. So, good point of clarification. All right, so this is the same formula, two different versions, because some people like the first way it's explained, and some people like the second way. So you figure out which one makes sense for you, and then you can choose, okay? So what we have in this picture, both pictures here, we have two chords that are crossing, okay? And the X and the Y, I think maybe let's start with the one on the right, the green circle. The X is the measure of this chord between the two endpoints of the chords, and then the Y is on the other side between those two endpoints. If you want the angle where the one of the vertical angles, right? Remember, angle 1 and 2 are called vertical angles anytime you have two lines that cross. If you want the measure of one of those angles, you add the arc measures together and divide by 2. Okay? Yeah, and I prefer this way. But if you want to use this way, that is fine as well. So it's going directly to angle 1. It's saying you could do half of arc QR plus arc PS. Yeah, so they both work. It really does not matter. I like this picture, I think, just visually, you know, more of us are visual learners. This one I think is more like written out style, and this is visual, like you can look at the picture and see it. So I think that's why I like the one on the right, but they are the same thing. Oh, I totally forgot about that, Ichiro. Okay, how about next time I will bring a picture of my dog. I gotta write this on a note, because if I don't, I will forget. And I also had a picture of the car, but I didn't have that either, so I will do both. Okay. Sounds good. Thank you for reminding me. See, I told you, Tiro, that I would forget. If I don't have it in my planner, honestly, I have to put in there to clean the coffee pot, because I forget if I don't have it in there. Actually, that's a problem right now, because something happened to my phone syncing up with my calendar, and half my stuff's not showing up, so I feel a little bit lost. But I'm going to have to figure that out soon, because otherwise I will not function. Okay, let's see if we can give this one a shot. Amelia, you want to try it out? Okay, Mason, next one. Amelia, I'll give you this one a shot first, and I'll turn on your mic so you can use your mic if you want to.
Okay, I had to wait for just a second because my brother was coughing downstairs. 6 people in this house. Okay, so what is the measure of angle AED if the measure of arc AD is 40 degrees and the measure of arc BC is 70 degrees? So, trying to find the measure of this angle, which I have highlighted in blue. And we're going to use the measures of these two. I'm going to use a different color here. of arc AD and BC. Oh dear, drawing with mouse is so difficult. And it says arc AD is 40 degrees. My handwriting does not look like this. And 70 degrees. So I'm going to write it out with the formula because it's just easier to write it out on the screen. So we're going to find the measure, measure of angle AED. Oh my goodness. And so it's going to be 1/2. Yeah, at least I'm speaking so you can see what I'm trying to write. Okay, and I'm just going to plug in the numbers here. So I'm plugging in right now. I'm plugging in AD, which is 40 degrees, and BC, which is 70 degrees. Ta-da! And I'm going to add those two together. 40 plus 70 is 110. And so then all I have to do is multiply 1/2 by 110, which is the same as 110 divided by 2, like in the other formula. And I get 55. Oh, dear, that factor's not terrible. What? Oh, I guess I got confused because I think there was another problem that had AEB. So yes, look how fast that turns into a B. Okay, so the answer should be 55 degrees. That's AEB.
Awesome. Give Amelia a round of applause. I love that you got on the mic. You did such a good job. That was awesome. Yes, actually, you were okay with the D here because it did ask for angle AED. But in the picture, what I was saying is you actually, let me delete this. You just marked the wrong angle. You did find this angle here, and that is what you were going for. So you did everything. That's what I was saying. You did everything totally correct, just on the picture. So we'll take that out and change it back to a D. But very good, yes. And that actually brings up a good point because the angle that you're finding with this formula is the one that's kind of like in line with the arcs. Yeah, so it's the vertical angles here. Yep. Very, very good. Beautiful. I love that. Any questions on this one, guys? Do you see how Amelia did this one and completed it? I saw some of you guys got it done before she did. But if not, and you were following along, just want to make sure it makes sense. Okay. Well, please feel free to speak up whenever it doesn't, because that's the point of class, right? If you knew it all already, you wouldn't need to come to class. So don't feel shy. You just type a question in whenever you have one. Okay, so moving on to 4.09, there's some more formulas. Unit 4 is really, really formula heavy. If you haven't noticed already, that's why I made a formula sheet. And like I said, as you go through Unit 4, if you notice, anything on that formula sheet that's incorrect or like omissions that formulas that you think are helpful as you go along that I don't have on there, let me know because I can definitely add those on. Oh, I like that it's your math scientist. That sounds really, really advanced. Very fancy. All right, so if we have an angle with a vertex outside the circle, these are some formulas you can use. So what that means is, like we're talking about these angles here, so you might have an angle that's formed by two tangents. So there's an angle formed here. I mean, there's actually 4 angles that are formed, and we could actually find any of those if we wanted to. You might also have an angle formed by a tangent and a secant. So we talked about tangent already, that it touches the circle in just one point. What about secant? Good question, Derek. It should already be in course materials. Do you know how to get to course materials? It's down at the bottom of that list. Okay, yeah, go down to the bottom of the list and you should see it. Let me know if you don't see it there. Good, so secant touches the circle 2 times, so this line is the secant line. It's kind of like a chord basically that just keeps going. And then you could also have one formed by 2 secants. Okay? So here's the formula, or one formula that's a possibility here. The angle here is half the difference of the intercepted arcs. So let me highlight these pieces here. So we have an arc. Oh, let me get my writing tool. That did not look good. Well, let's try this again. Okay, so we have this arc. Yeah, well, see, I was trying to use my mouse, and that's what happens. I got to use this. I have like a little tablet, you know, that they use for like graphic design and stuff. That helps a lot. It'd be really hard to write math on the whiteboard without it. So, anyway, yeah, there you go. Try plugging it in. Maybe that'll work. Yeah. But if you do like the green minus the blue, this is getting really technical. Okay, and you get your answer, and then you take half of that. That's what that's saying. Okay, so it's saying you take half of the difference of the intercepted arcs. So difference means you subtract, right? So you just take these arcs and subtract, and that answer, whatever you get, you take half of that. And that's actually this angle down here. So let's see if we have an example. If we actually work through an example, that helps a lot, right? All right, let's see who is that line down. Okay, Mason, I'm going to give you whiteboard privilege and my privilege if you choose to use it. All right, go for it. Okay, excellent. Mason's off to a great start. So notice here it's kind of at first tricky because they only give you one arc. So they gave you the measure of arc AB right here as 130. And yes, that was a pretty good one, huh, Amelia? You definitely had to think about that one. I like that, Atiro. So this is 130. And he said, okay, well, I know the whole circle. Like if I went from point A all the way around to point A, I know that's 360. So if I subtract 360 and 130, I'm going to get the other arc that they aren't giving me. Yeah, I see what you're saying now about color math. Yes, I like that, Atiro. Very good. Good, very good. You see, do you guys agree with Mason's answer? So once he found out that this arc over here is 230, he took 230 minus 130, subtracted the two arcs, and then got 100 from that, and took half of 100 to get 50. Good. So this angle right here, angle APB, would be 50 degrees. Excellent. Very good. Very good. Does everyone, that one has a few different pieces and steps to it. Does everybody follow along there? Yes? Okay. Very good. Very good. All right. This one is the same formula, but we don't have specific numbers. You have to figure this out in a general sense. All right, Derek, go for it. I'm going to give you whiteboard privilege and mic privilege if you want it. Now, this one's really tricky, so if you need help, don't hesitate to let me know. You guys try it out, because this one's really Really, really tricky. Yes, Dick, on this one here, you would just say arc AB. You're talking about this arc right here, right? So if it's less than half the circle, you just use 2 letters. So you'd want arc AB. Yep, there you go. Just take out that. Well, you know, to tell you the truth, I don't remember off the top of my head. And there's a bunch of different answers in the polling, so we're going to have to keep going. But this is beautiful to start with. Can anyone help Derek from there? So he has the formula set up for us, which is great. Okay, so take a step back and plug in what you know about these things. What do we know about ADB? Okay. Hang on there, Tiro. That's correct. Let's start with ADB. Yes. Good, Anthony. So we know that ADB is equal to x. So I would say the measure of angle APB. So I'm just taking Derek's formula and I'm going to rewrite it, and I'm going to plug in what I know. I know that ADB is equal to x. I don't have a number for it. It tells me in the problem up here that arc ADB is x. Then I'm going to subtract AB. Okay, so here's where it gets tricky. If this was 300, what would you do to find AB? Tell me the process. What would you do? So if you actually had a number over here for angle or for arc ADB and you knew it was 300, what would you do? Yeah, you'd take 360 minus 300, right? So even though this is x, apply the same idea. What you would do to get this angle is you would take 360 and you would subtract the other side of the circle, which is x. Does that make sense? So we can represent arc AB as 360 minus x. Basically, you're describing the process that you would take to find it. You're saying, okay, if I actually knew what this number was, I would take 360 and I would subtract that number. And that's how I would figure out what arc AB is. Does that make sense? Okay, now that we know that part, well, hang on, Anthony, we're not quite there yet. What we're actually doing right now, what we've done so far is okay, so let's follow along. So we have, I'm just taking Derek's formula. So he said the angle that we're looking for, which is angle APB, is equal to 1/2. So I'm just so far copying his formula. Yes, hold your horses. ADB was x, so I plugged x in right there. Now we're going to subtract AB. So Derek, I'm actually going to move your B up here if I can. Okay, so we'll just delete this part. Oops. There's something I meant to delete. I always do that. Just moving the parentheses. There we go. Okay, so here's what Derek told us, when that's totally right, that this is the formula of how you would find. And now we're just plugging in what we know. Okay, so we know that ADB is X, and then we know AB is 360 minus X. Okay, so I have 360 minus X. Now notice I put parentheses around that 360 minus X, so be careful because you do need to do that. And the reason you need to do that is because AB is this entire thing. You need to make sure you subtract that entire thing. What's going to happen, okay, now this part's getting into algebra, okay, so if you're struggling after this point, don't blame it on geometry, blame it on your algebra skills, okay, but don't stress, we're going to improve those algebra skills right now. What are we going to do with this minus sign? If you have a minus sign and it's right in front of parentheses, what do you have to do with it? It starts with a D. D-I-S, there's a fancy math word. There you go, Anthony has it. Distribute. Very good. Very good. Oh, sorry, Nate. Nate knew it. We didn't get his answer in there. But you're going to distribute. Okay, so be careful. You guys can do this. It's just tedious. Make sure you don't mess up. So we have X minus 360 plus X. Does everyone agree there? Okay, so be careful because minus times this minus is where the plus is coming from. Okay, now inside the parentheses, we have an X and another X. We can put those together. Good, so we have 2X minus 360 inside the parentheses. Okay, Anthony, now it's time for the 1/2. What can we do with the 1/2? Yes, it is for multiplication only, Atiro, and what this actually is right here is a -1 sitting out there. So you're multiplying that -1 through that entire parenthesis. Very good, Emilio. That's also what we want to do with the 1/2, is we want to distribute it. Now, Anthony, that is true as well. You can actually apply both of these. You can either think of it as distributing or dividing. But really, even when you're dividing, you're distributing the 2 in there. You're just thinking of it as dividing by 2, but you are doing it to both terms inside. So distribute just means you need to take the 1/2 and apply it to the 2X and the 360. Hang on, Atiro. Or hang on, guys. Let's go back. So, Atiro, I think your question is here. Why did we change this to a minus and this to a plus? So the 1 is always sitting there, Atiro. Like, for example, when we have X up here, like if I just write X, there's always a 1 sitting to the left of that X. Even though we don't write it there, it's always implied that it's there. So the same thing here, it's not just minus, there's always really a -1. It's just that sometimes if it's a 1, we don't write it there. Not quite, Atiro. So the 1/2 has not been applied to the X yet. We're doing that down here. So remember your order of operation. Please excuse my dear Aunt Sally. You want to work inside the parentheses first. So that's the reason that we are working first with the 360 minus X. And we're distributing the -1 to get to this step. Then we combine like terms to get to this step. And now that we're done inside those parentheses, we're working on the 1/2. So good, this looks good. So, yes, so the 2X, when you apply the 1/2 times 2X, this is what it looks like. You have a 2X in the numerator and a 2 underneath, and those 2's cancel. So you just get X, and then 1/2 times 360 looks like this, 360 over 2, or 360 divided by 2, which is 180. So you end up with x minus 180. So that's right. D would be correct. Yes, and that is exactly what we did there, Amelia. We wrote it differently, but that's exactly the same process. So that's correct. Yeah, so it's just writing it a different way, but right. So it's totally up to your preference. And I would agree that's kind of nice to write it that way because then you don't have to think of it as distributing, but it is, Derek, you're right. It is time to end, right? All right. Well, we went over this is probably the toughest one of the day, so we got that one done. Hopefully the rest of 4.09 will be easy peasy from there. And if you guys do have questions, I will see you in tutor time.